And with that, we just continue, and I'm happy to welcome our next American guest from the US, from Dolby in San Francisco, Jeff Reidmiller. He is with with a group in San Francisco, and is the director of the Sound Platform Group, and has been dealing with loudness levels and coding since all his career in Dolby, which is many, many years now. So, Jeff, please.
Thank you. Good afternoon. Good seeing so many familiar faces on a topic that's near and dear to all of our hearts. And hopefully I'll share some points from you, that Dolby's been working on for many years, and also share with you some late-breaking data and some thoughts around where we should go next. So I got to figure this stuff out here. So when we start talking about loudness, when you look at loudness holistically across the chain, as everybody's been talking about this morning, you have to think about the creators, the distributors, and the devices themselves, the things that consume and eat the content everybody creates and tries to do something with it to make it sound good on the wide range of devices now that media gets consumed on. Obviously, many people talked about it this morning. The best way to do things is by ear, and the greatest place to create the best intent for any device through any distribution channel is as far upstream as you can get it, at the content creation stage. A lot of good, highly skilled people put a lot of time and effort up there. Even better yet, if you have, again, human beings with ears, really skilled at that art, involved in the distribution of the content as well. And that still happens from place to place throughout the world. But that's slowly, kind of becoming a smaller and smaller universe, and has been for some time, which has kind of been the root of some of the problems we've been experiencing over the years. And finally, in the device. And when we talk about this stuff, when I talk about devices, I mean this in plural. There are a number of devices, device types, capabilities, and things like that challenge us when we want to create a nice piece of compelling content and do it efficiently. Do it in a way that it'll play back at the right level, the right amount of dynamics, and give the right experience no matter what type of device it's being played back on. So underneath these boxes on distribution and device, we start talking about intra-program dynamics. So this is within a program, the moment-to-moment changes in loudness. And I think Florian and others talked about that this morning. It's natural to have that stuff, and that's fine. And at best, when people are mixing, skilled people in the art of mixing, they do a very good job of managing that. By using their ears and their skill. Down at the device, basically all the user is doing, they're just controlling the volume control in a sense to try to set that program average loudness to one point. At the beginning of the program, you might make a slight adjustment, and if it's mixed really well, produced really well, and playing back at the right level, there's really should be no need to make adjustments to the volume control. Again, takes a lot of effort to make this happen in that way. I mean, this has been the Holy Grail, and still is realized in many parts of the world. But some people want to, now that we have regulation on our backs, especially in the U.S. as we talked about earlier, in some cases this has caused a bit of a knee-jerk reaction, and everybody's just going and running and just throwing single-ended processors in the chain just to cover themselves. Because in the Column Act itself, in the legislation and the report that the FCC put out, there's this safe harbor clause. And safe harbor, basically in a nutshell says if you install and maintain equipment that's compliant with 1770 to control loudness, you're signed off in a sense. So this has caused a lot of people to just, go to the extreme, throw processing in, I'm done, my hands are clean, and the heck with any artistic intent now. And that's the big worry that everybody, I think, has been talking about here this morning. So the theme continues here. The other problem I want to talk about a little bit here is what happens when these things are in cascade. You have a processor in creation, potentially, one in distribution, and one actually in a device, in the TV or set-top. These things are all operating blindly. They may take measurements, over a small amount of time, differing amounts of time. They may use different, measures themselves, make different decisions, and apply corrective action differently. And you put these things in cascade. We've even seen it. I've even done some research on this and done some analysis on this, and it's scary. Going from the days of analog television, where the dynamic range was obviously very limited because we had an analog system and the signal and noise in receivers was often poor or unknown, so the best thing would do is run the speech peaks up to 100% modulation. In the US, that would be 25 kilohertz peak deviation as often as you can to overcome that. And then the day digital started its transition, everybody took the processors out, and a lot of material that was all over the map started going all the way through to the home. And now I'm worried that we're going right back to NTSC audio, in quotes, if we're not careful. If people like yourselves and the people that have been working on this stuff worldwide across Europe and in the US don't come together and align ourselves. So basically this becomes, Band-Aid to the solution, to the problem. Yeah, you can solve it, but we can do much better. The whole purpose of loudness control is basically, you could ask yourselves, is to stop the phone from ringing with complaints. Do you want a regulatory agency or body to keep from fining you? Or do you want to just reduce the need for the audience to mess around or have to adjust the volume control quite often? And obviously I think we all believe in this room, that's the ultimate goal. We don't want to annoy them. Those are the people that support our advertisers, support our programming, so on and so forth. So why all the fuss about loudness now? The genesis of this was really kind of set in motion over 20 years ago. Our company had been deeply involved in cinema over the years, multi-channel audio. But multi-channel audio in cinema, all that content gets mixed in a calibrated environment. And because when that film is distributed, all the theaters, they couldn't run around and change the volume between every movie. So there had to be standard practices and approaches put in place upstream such that when things go out to the theaters, you get a nice consistent experience without a lot of monkeying around. The other thing too to remember is when you're creating multi-channel content for the cinema or for theatrical distribution, it's never down-mixed either. You're always hearing 5.1. And that's another challenge. So these challenges became apparent when the early days of digital television came along and optical disc and things like DVD that now could take this information and deliver it right into somebody's living room for the first time. So it's a huge step in experience, huge step in immersion in terms of bringing Hollywood's intent right to somebody's living room. This is the first time this has happened in history. But there's a challenge with that. Again, as I touched on, we had to come up with approaches to take that wide dynamic range theatrical release in multi-channel and be able to deliver it efficiently to somebody that had a monophonic television set that sits on the kitchen counter, all the way up to the home theater enthusiast. And what do you do? How do you just create several different mixes and send them all together and it gets sorted out at the end? The receiver just picks the mix you want and away you go. We thought that, no, there's a better way to do this. Why don't we create some sidechain information? We're carrying bits, ones and zeros. We're carrying the essence itself in an efficient form using psychoacoustic principles to reduce the amount of data that represents that experience. Why don't we create some of this information to kind of help and guide the receiver, whether it's a 2-channel receiver, a mono receiver, a 5.1 receiver, to actually render the most optimum experience for that device itself. Seems great idea. Conceptually, it sounds great. The other thing too, why don't we avoid trying to have to get everybody to come across the bridge and agree on a single loudness to mix to? Back then, today I think it's a little different, and we've seen some success in doing these things, but back then, that was a tough hill to climb. So why don't we, send some information about the loudness of the program? Why don't we send information about the dynamic range of the program that could be leveraged under certain conditions and within certain devices? So the system has great potential. And this is back in the mid-90s now. I'm kind of rewound back into the mid-90s, the beginning of all this. That Hollywood to home experience is something that I think, all of us in this room and our colleagues share in audio. I think Florian and others have talked about it for years, that the video engineers and stuff would always I remember where I used to work for for Time Warner Communication, and a lot of my colleagues in the engineering group are video guys and RF guys, and they wouldn't even listen. All they do is look at the meters and see them twiddling and go, that's fine, it's working, when there was big problems. Only if they listened. You go into master control sometimes, they'd have the volume down. I remember modifying amplifiers, actually ripping the attenuators off them and hardwiring them so the master control operators could not change the level. They hated me for that. I think they toilet papered my car or something in the parking lot, after that. In the end, the danger, I guess, with this great potential, or the risk, is we must balance, a wide set of consumer desires and the capabilities of all the devices that would receive this theatrical audio. And that's what kind of brings us to this point now. What do we do, and how do we do this? In a way, we're in the second decade of the 21st century. Let's really do this and leverage what we have, what we've learned, and not let this go back to 1975. Again, it's been a long, long journey from theory to acceptance, practice, and success. We've seen lots of success in the past handful of years, and a lot of it's education. It's not really hard. Once you understand this, some few key concepts, it becomes very, very easy. So what I'm going to do is just take you through a few things. I'm not going to go into any great detail. A lot of detail has already been shared with you. It all starts, kind of what Florian and Pat and Tim and Randy talked about earlier. A lot of work, good work, has been going on with two main bodies, the ATSC in the US and the EBU PLOU group here in Europe. A lot of great minds, a lot of great creative people get together and try to align themselves in one direction. Even previous to that, there's been a lot of study at organizations worldwide, research organizations, universities, our company as well, in how humans perceive loudness and what is it, that will meet the test and satisfy most listeners' needs. So all the work EBU, the EBU PLOU group has done is generate a lot of great documentation for us to share and follow and guide our steps, as well as the ATSC A85 document. And as Pat and Tim mentioned earlier, there are a few key differences, and I think the two main ones here are the 1770-1 reference and this concept of anchor element. And it was brought up a little earlier, and typically the anchor element is speech for most programming. So going way back, even before the ATSC work commenced, I went back to some of my archives on our server back in San Francisco in the lab, and dug out some loudness ratings. Years ago, and this is going back 10 plus years ago, this predates even the development of the LM100, our loudness meter, our first loudness meter we released back in late 2002. To just demonstrate again the importance of putting a loudness measure, focusing a loudness measure on some context. And the whole reason we really feel strongly about using dialogue as an anchor, or speech as an anchor, and program is really demonstrated well by this correlation histogram. This is one of N histograms I have. I figured I'd pick one and share it with you. Some of you may have seen this before in the past, but I think it really demonstrates the point. These loudness ratings were going to be used. These are basically subjecting human listeners, providing loudness ratings to us, such that we can evaluate measurement methods to make sure the one we choose is the most highly correlated with listeners. You can see there's two types of content that are represented in this correlation histogram. One is speech, and one is other. And the other, in this case, was actually a scene from a television show where somebody was walking down a hall. All you heard were footsteps, in a bit of a reverberant environment. And 21 people were in this test. And you can see, if you look at the other distribution, I don't know if there's a laser pointer on this, is there? I can't tell. Green? Oh, there it is. Okay, thank you. So if you look at the yellow distribution here, that's 21 listeners giving us loudness ratings on the gain they needed to apply to that item, the other item, the footsteps, to get it to agree by ear to the reference item. You can see that wide range of results here. One person says, I need to turn it up by 9 dB. Another person in that same group said, no, I need to turn it down by 3. Huge variance. You compare that with something that was dominated by speech and dialogue, which is obviously present in quite a bit of our programming we deliver to consumers. That same group of people, 19 out of 21, agreed with each other to within 1 dB. This kept appearing in these loudness ratings, this pattern. And we said, wow. And back then we had LEQA, and I think somebody touched on it, I think Randy touched on that earlier. Back then we had LEQA. LEQA works great with signals that have similar spectra. One speech signal to another actually works pretty good with LEQA. So why not, build some mechanism to actually gate, an LEQA meter on speech. And that's kind of what led to the development of the LM100 and everything else we've done. So I wanted to share with you kind of some of the history going way, way back, why we landed where we landed. We've done a lot of work on algorithms that are actually classify speech. We also offer this algorithm now free of charge. You can go to our website and download the source code and build your own, dialogue gated meter if you'd like. So a lot of work went into it. I won't go into the details on how we do it. If you want, you can see me and I can take you through it. But where the rubber meets the road, a lot of our technology components and solutions have leveraged this for years. And tens of millions of programs have been corrected using this approach, using the dialogue anchored approach that's prescribed in the ATSC A85 document. And it's coupled with 1770-1 without any operator intervention. This stuff gets handed to that system, like any file-based workflow gets handed to that process. It's analyzed, corrected, and put out. Nobody ever listens to it again. So a lot of faith and trust has to go into that process. So I wanted to share a little bit of feedback that's been coming up through the ATSC and back to us in San Francisco that do research on loudness on 1770-2, because a lot of meters now and a lot of file-based workflows are starting to implement the changes that 1770-2 brought, and this is the foreground gating mechanism. Few programmers that are involved in delivering theatrical type content, and even some networks that deliver television dramas. Now the television dramas, multi-channel television dramas, have a wide dynamic range as well. When you watch CSI or 24, things like that, on television networks in the US, it's very theatrical, very wide dynamic. And they're starting to, some of these guys are starting to say, hey, wait a minute, I'm seeing some inconsistencies with the -2 approach. Especially when you normalize a piece of content on the 1770-2 approach, the wide dynamic range multi-channel stuff, and it's butted up against a 2-channel commercial. It's kind of aggregated the delta between the two, and it's really, kind of causing some people to scratch their chin a little, and some, I'm told, are even reverting their software back to 1 right now until they figure it out. So we're working with them, and I know a lot of others are. I know Tim's involved in this as well. The ATSC, Pat and his team have been discussing this with the people that have brought this up through the ATSC. So I think, for us, a little bit more study, it must be done to understand what's really happening here. Obviously, to resolve and potentially amend any standards, RP, if necessary. We need to go back and take a look at it. And I think Florian touched on it earlier, the wide dynamic range stuff is definitely, it can be, a challenge. So we just got to understand that a little bit more. So content to device. So you have programmers, BBC, ORF, French television, feeding content over many different distribution mediums now. You want to feed this stuff not only to, years ago, you wanted to feed television directly, or you wanted to feed the home theater enthusiast, but now you've got all these other devices. You've got portable devices, and these things run, the gamut in terms of, their capabilities, the amount of output they can deliver over the internal speakers, headphones. Some of them have HDMI outputs on it. It creates another challenge as we want to deliver our content across a wider range of devices and delivery mechanisms. So in this case, why not, again, the device should be able to leverage some information created by everyone in production, everyone in content creation. Again, this is the loudness and dynamic range control metadata that we've been talking about all day today, and let the device itself, and sometimes the user, actually have a choice on, how much dynamic range they want to render at a given time. In portable devices, minimum dynamic range or a profile that's tailored for that type of device, whether you're listening over earbuds or internal speakers, they might not, need a choice. Just give me the minimum dynamic range and the right level, and I'm done. And if I plug that system into a dock, an HDMI dock, an interrupt is generated, and the decoder can go into the wider dynamic range mode and feed that over to your AVR. These systems have been deployed today, and give us the ability to create one stream that satisfies many listeners and device types without a lot of monkeying around, a lot of inefficiency in creating multiple pieces of content for these different device types. When we talk about, optimizing content, at the right level and the right dynamics, we often talk of decoder operating modes. Historically, in our legacy modes, our line and RF mode, line being our mode that provides the, cinematic type dynamic range, with a reference loudness of -31 below full scale, so -31 LKFS or LUFS. RF mode, again, gives us that NTSC-like dynamic range and operating level, again, closer to 0. And we've developed a new mode for portable devices. And this is going to be rolled out this year in our decoders. And it has a reference loudness target of -11. And this was based on a study that myself and a few colleagues did a couple of years ago. And we actually published a paper on this in the AES May of 2010. I think it was the AES here in London. And I believe that paper is on the USB stick that was out front, if you're interested in reading it. So again, all these modes leverage that metadata that's been created upstream in the production process, or it can leverage the metadata created at ingest or QC, whatever. This stuff can get created and generated anywhere, really. And we have mechanisms now, and there's a lot of tools by a lot of companies that can actually do this to your liking now. So it's not, you don't have to completely rely on everything upstream, but there are tools and systems that support the generation of this stuff downstream as well. And I think the important thing to note about decoder operating modes and these reference levels is that line and RF have really established a lot of basis for gain structure in products worldwide. And we've even developed recommendations with the CEA. We've also published tech bulletins as well to help set-top manufacturers, AVR manufacturers, TV manufacturers basically manage levels and the design of the gain structure in those devices. That's a key element to all of this. However, in the portable mode market, tablets, PCs, phones, things like that, it's the Wild West right now. And we did this, we put together this portable mode reference level, and we're going out and hitting those guys hard and trying to establish that as a basis for gain to be fed out the internal speakers or earbuds, things like that. So a lot of work's going to continue in this area. And now I'll just wrap up and take any questions. So to sum up at least some thoughts on inter-program level differences. These can and are being solved worldwide. The great work that the P-Loud group and ATSC and others have been pushing hard for, and everybody embracing it in the creation and distribution and broadcast industry is a test to that. We feel the best practice is to communicate the program loudness to the rendering device itself and let that device, based on its capabilities, either by default or through user input, decide how to render that content, both in terms of dynamics and reproduced output level. That's done through things like dial norm and AC3 and EAC3, PRL, program reference level, and AAC. And even you can take this concept to files as well, iTunes files, MP3 files, using replay gain, something called replay gain. And as a catch-all, you could leverage single-ended loudness and dynamic range control as a last resort. I think there's more work to do there to make these things maybe smarter or connect them into the system much better so they don't undo good work that's been done upstream. And again, I think the overall point is we shouldn't overbake it. This is simple. And I think, Florian drove that point home. This is really simple stuff. It's not rocket science. And we got all the tools. The moment-to-moment dynamics in a program can be solved as well through, more sidechain information that allows the dynamics to be tailored to a specific device. Again, this is through DIN range and copper and also the equivalent of those fields in AAC. That stuff's been specified for years. It exists. We should be leveraging those things. Should be driven by the content creator. What a concept to be able to sit there in production and actually author some of this stuff and emulate what would happen when it plays on my iPhone or my iPad. Blind single-ended processing has its applications, of course, and pros and cons. We got this predictability issue when several of them are in cascade with each other. Again, the content creator has little or no control over the rendered experience in this case. Compliance, long-term versus short-term. I measure my program on long-term, I'm compliant. It goes through a single-end leveling process. How do you deem compliance then? And this is it's kind of getting into some real gray territory here. So ultimately, we can do much better, and we've been continuing, to research and develop next-generation systems. And stay tuned in 2012. we'll definitely keep you posted. And last slide here, we certainly, I feel, and I think, hats off to everybody in the industry. We've come a long way over the past few years in realizing and coming together on this problem and addressing it with passion and vision to really keep, the great work that's being done upstream, kept alive through this complex, these complex systems. So, hats off to all of you, and I appreciate you letting me come up here and speak. So, thank you.
Thanks, Jeff.
Yep.